Hello everyone, this is Amirul Hakimi from MRSM Kota Kinabalu, and today I am going to talk about this puzzle. This is the Tower of Hanoi, or the Hanoi Tower, whichever you prefer to call it. You may have seen this before, as this is a very popular puzzle. This is due to the puzzle looks very simple, but in reality it is quite a challenge, especially if you are not experienced. So let's first understand this puzzle. We have 3 poles and a number of discs. At the first pole, the goal is to move all the discs to the third pole with the minimum moves, while also obeying this rule. The first rule, only one disc can be moved at a time. The second rule, larger discs cannot be on top of smaller discs. The third rule, only the top disc can be moved, which means we cannot take the one that is under another disc. Sounds easy, right? So let's try to solve this puzzle with 4 discs. Okay, so let's move this one over here, and then this one over here, this one over here, so that we can move this one, and then okay, I think we got it, but we didn't get the minimum move, which is 50. So as I said, it looks simple, but the guessing is not the way. So even if you manage to do it smoothly, you might end up on the wrong pole, which is very frustrating. So is there a strategy to win this game every time flawlessly? Well, actually there is, and the concept of the strategy is actually in this textbook, Mathematics Form 4, Chapter 2, Number Bases. Wait, what? How does number bases is related to this puzzle? Let me explain. You may have known that the formula for the minimum moves is actually 2 power of n minus 1, where n is the number of discs. So if we have 3 discs, we need to move at least 7 times. If we have 4, we need 15 moves, but the magical part comes when we convert these numbers into base 2. So how are we going to do that? Using the method we have learned, repeated division, also known as division using the base number. So 7 divided by 2, we get 3 and remainder 1. Divided by 2 again is 1 remainder 1, and finally 1 divided by 2 is 0 remainder 1. Reading the remainders from bottom to top, we get 7 in base 10 is equal to 111 in base 2. For 15 divided by 2 is 7 remainder 1. 7 divided by 2 is 3 remainder 1, and 3 divided by 2 is 1 remainder 1, and 1 divided by 2 is 0 remainder 1. Again, reading from bottom to top, we get 1111. So 15 in base 10 is equal to 1111 in base 2. So you might be thinking, why there are so many ones? Well, have a look at this table. All of the numbers of moves with any number of these result in so many ones when converted into base 2. Interesting, right? So what does that mean? If you look closer, the number of 1 is the same as the number of discs. Like here we have 3 ones and 3 discs. Same goes to the other. The truth is that each one of these represents each of the discs. Okay, have a look at this. I have colored them so that it makes more sense. So each number represents each disc. Like the first number represents the smallest disc, and the second one represents the second disc, and so on. All of the number being 1 means that they are all at the final position, because this is the minimum and the final move. So if you think logically, we just need to count to that number, right? Because that is the final move. How do we do that? The answer is by counting in base 2. But before that, we need to consider the pattern of the first disc, because this is very crucial. So the first disc must follow a pattern depending on the number of discs. If the number of discs is even, we need to move the number 1 2 3 1 2 3 1 2 3. But if the number of discs is odd, we need to move the first disc 3 2 1 3 2 1, 3 2 1 like that. So now we will solve this using base 2 counting. Okay, so let's try with 3 this first. So we need to move the first one. This is an odd number of this, so we need to move from 3 to 1. Okay, so let's put it to 3, and then we need to move the second one, so we have no choice but to move it here, and then the first one again, so follow the pattern, and then the third one, and then the first one, follow the pattern again, and then the second one, we have no choice, and then the first one again. So look at that, 1 1 1, which means all the discs at the final position, and tada, we have solved it, and we got the minimum move just by counting in base 2. Just to show this is not a fluke, let's try with 5 discs. Okay, here we go. And the cherry on top of the complete tower. So look at how easy it is. We just need to count in base 2 and we can determine exactly which disc we need to move in the most accurate order. But how the movement of this can be represented by the base 2 number? Is that the only thing we can count like that? What if everything on earth can be represented by numbers? That is the mysteries of mathematics. That is all from me. Have a good day.